Hello, so I welcome you all for this presentation. So in this presentation, we'll be looking at the solutions for previous appeared CSIR NET questions on Jahn Teller distortion. So I have made a video totally explaining this Jahn Teller distortions, and in that video at the end, some 5 questions which have appeared in previous year CSIR NET examination, that those questions were given to you. So those who have not seen video, I request you to watch that video first and then try to solve those questions by yourselves. And finally, you can just verify the solutions of the answers that you have got with this. Okay, let us begin. So the first question. So it's simple. The correct statement of MNO bond length in MnH2O 6 times 2 plus, right? So simply this is about again Jahn Teller distortion. If Jahn Teller distortion is possible, so as you know, in that case bond length, axial and equatorial bond lengths, that will vary. But if Jahn Teller distortion is not possible, in that case you can expect ideal octahedral geometry, and in that case Mn to H2O bond lengths, they will be identical. So now to predict whether Jahn Teller distortion is possible or not in this case, so Mn H2O 6 times 2 plus, in this case Mn it is in 2 plus oxidation state, it is a d5 system. I hope you can easily find that this Mn 2 plus system, it is d5 system, and water, it is acting as weak ligand. So therefore the electronic distribution according to crystal field theory, if you write, it will be like this: T2G and Eg, T2G3 and Eg2. So this is even distribution, right? So T2G, it is evenly distributed. Even in the case of Eg orbitals, it is evenly distributed. And as we know, if electrons in T2G level and Eg level are evenly distributed, then in that case we cannot expect any Jahn Teller distortion. So no unevenly filled T2G or Eg orbitals, in other words, in this case. Therefore Jahn Teller distortion is not possible, and therefore answer for this question, it should be this: all bonds are equal, option A. This is the answer for this question. Okay, let us go to the next question. Okay, fine. Next question. So again, in this question, what they have done is some 4 complexes they have given. All are hexaequa complexes. In all these cases, water, it can be treated as weak ligand. So the thing is that just we should identify what system it is: Ni2 plus, what system it is; Mn2 plus, what system it is. And then for octahedral crystal field electron distribution, we should write, and we should just find out whether Jahn Teller distortion is possible or not, right? So that's the question is. In other words, ideal octahedral geometry will not be observed in, they have asked, which simply means that where Jahn Teller distortion is possible. Wherever Jahn Teller distortion is possible, definitely there will not be ideal octahedral geometry. It will not be observed because of Jahn Teller effect. You can expect deviation from octahedral geometry. If you look at this first complex, NiH2O 6 times 2 plus, it is D8 system. Ni, it is in 2 plus oxidation state. You can identify this to be D8 system, and electronic distribution, it will be this T2G6 Eg2. It is uniform distribution, and therefore definitely it should not be showing Jahn Teller distortion. Come to this Mn, it is in 2 plus oxidation state, right? So Mn, it is in 2 plus oxidation state, which is d5. Last question we dealt with the same question, right? So here also it is even distribution, no Jahn Teller distortion. Again this one Cr H2O 6 times 3 plus octahedral complex, Cr, it is in 3 plus oxidation state. Again it will be d3 system. Hope you can identify this. Again it is T2G evenly distributed, Eg0. Eg0 is also even distribution itself. So therefore this configuration will also not show any Jahn Teller distortion. Whereas this last one, hexaequa titanium 3 plus, in fact this is typical example which will be taken to explain this electronic spectra, and the electronic spectra of this complex, it will be broad, and the reason for that broadness, it is again this Jahn Teller distortion itself. Fine, here it is titanium, it is in 3 plus oxidation state, which turns out to be D1 system, and unevenly filled T2G orbital is present, right? So when electrons are present in electrons are distributed in Eg orbitals unevenly, definitely prominent distortion, Jahn Teller distortion, will occur, and reason for which you already know. Similarly, even when electrons are unevenly distributed in T2G orbitals, there are also some Jahn Teller distortion you can expect. Definitely Jahn Teller distortion is possible. So in these 3 cases it is not possible, whereas only in the case of 4th complex it is possible. So therefore answers, if you look at this, should be the answer. Option D should be the answer for this question. Fine, let us go to the next question. In fact, this is a very interesting question. Out of all these questions, I would consider this to be a good question. So what they have said is 2 complexes they have given. Just look at the formula of both the complexes. Both are nitrite complexes. This is NO2 minus nitrite ligand. Both are nitrito N complexes, right? Hexa nitrito N complexes. Same coordination environment point of view. Both the complexes have got similar coordination environment. So these two compounds, they are just differing in this outer cation. In ionization pair of first complex, you have potassium ions. Here you have cesium ion. That is the difference, right? But what they say is this A and B, this they have identified to be A, this they have identified to be B. So they say that A, it shows tetragonal elongation, that is Z out distortion, and the other one, it is tetragonal compression, which is Z in distortion respectively. Now the question is, the unpaired electron in A and B are found respectively in orbitals. So one point that should be kept in mind, unpaired electron, where unpaired electron lies, that has been asked. Okay, how we can solve this question? See, first complex, they show that it is elongation. So elongation, it simply refers to Z out distortion. So two ligands which are present on Z axis, they move away, right? So you have seen this in case of in my previous video, this has been explained. So now first, before going to this, you should identify this to be Cu2 plus system. Say this is K2 and B8 is in 2 plus oxidation state. Totally this makes 4 plus charge, therefore this should be 4 minus. This is NO2 6 minus, and therefore it should be 2 plus. Copper oxidation state, you should be able to identify it in both the complexes to be 2 plus, which is a D9 system. Right now, elongation, because of elongation, energy of Z square orbital it decreases, and because of the same reason, energy of dx square minus y square orbital it increases. Right now, if you distribute the electrons, you can write the whole electronic configuration and you can just check. So what I have done is, will be Eg3 configuration, just those Eg electrons I have shown here. So they will be distributed this way, and therefore unpaired electron, it should lie here, dx square minus y square orbital, in dx square minus y square orbital in this complex where it is tetragonal elongated. Then come to the other complex. If you come to the other complex, here it is said to be compression. So Z compression, it leads to increase in energy of the orbital which is oriented in Z axis. Therefore dz square energy, it increases. Say earlier both of the Eg levels say somewhere here. Now after this compression, Z square energy level increases, x square minus y square energy level decreases. It was Eg3. So if you write here the electronic distribution of D9 in octahedral field, it will be T2G6 Eg3. So Eg3, if you redistribute it after compression, x square minus y square, it will get pair of electron, whereas unpaired electron goes to dz square, and therefore the corresponding answer should be, respectively in both these cases, unpaired electron should lie in dx square minus y square and dz square. So that is this option D, dx square minus y square and dz square. Option B is the answer for this question. Then next. See, this was a simple question. So if we have solved these three questions, it should not be definitely difficult to you all to solve this question. It is just about these two complexes, hexa aqua nickel 2 plus complex and hexa aqua copper 2 plus complex. Again, if you write their crystal field electronic distribution, say it is D8 and it is even distribution, T2G6 Eg2, it is even distribution. So in this case, no Jahn Teller distortion. Whereas in this case, if you look at it, is a D9 system. Right, so here I have missed electrons. In fact, it is D9. So these all three electrons, they must have been paired. Please note this change. Right. So if you consider here Eg, it is now it will be say unevenly distributed, because of which Jahn Teller distortion is expected. And because of Jahn Teller distortion, and whenever it comes to Jahn Teller distortion, most common, as I have mentioned, it will be Z out distortion. But let us look at the statements what they have given. First statement, if you look at, all NiO and CO bond lengths, they are equal, they say. No, it is not possible. So because here Jahn Teller distortion is possible, here it is not possible. So what I can say is, first option, definitely it is not the answer. Second option, nickel O equatorial and CO equatorial bond lengths are shorter than nickel oxygen axial and copper oxygen axial ones respectively. Right. So what they say here is, nickel to oxygen equatorial and copper to oxygen equatorial bond lengths are shorter in both the cases they are mentioning, which is not possible, because in both the complexes we are not expecting Jahn Teller distortion here. So in only one case, copper complex, we are expecting Jahn Teller distortion, whereas in case of nickel, no. So therefore what we can say is, this option B, definitely that is also not the correct possibility. So if you look at third option, so third option, what it says is, all nickel O bond lengths are equal whereas copper O equatorial bonds are shorter than copper O axial bond lengths. This could be one of the possible. So in case of nickel complex, no Jahn Teller distortion, therefore all bond lengths they are expected to be equal, and that is that. So further what this is, copper oxygen equatorial bonds are shorter than copper oxygen axial bond lengths, which simply indicates Z out distortion, right? So Z out distortion is possible, so therefore this is possible. This can be the answer. We can just verify the last option to all copper oxygen bond lengths are equal, whereas nickel oxygen bonds are shorter. See what they say is, first point itself, all copper oxygen bond lengths are equal, they say. It is not at all possible, because in case of copper we are expecting Jahn Teller distortion, so therefore option D, it cannot be the possibility. We are left only with option C, and that seems to be the correct answer. Fine, let us go to the last question now. Alright, this is also simple, just as we have done in the case of earlier questions. What we are supposed to do is, we should write electronic configuration, and then just we should find out where Jahn Teller distortion is possible. That's what they are asking. Jahn Teller distortion is expected in. Right, so I have given electronic configuration for all this, but here the point is that you should identify the charge on this complex properly, and based on that oxidation state of metal ion is to be identified properly. Otherwise definitely there are chances that you can go wrong with this question. So I have done it here. So first question, if you look at, so this one, it is a K4, therefore this will be 4 minus, and Cn6 minus, therefore it should be Cr, it is in 2 plus state, and D4 system it is. So D4 strong field ligand, and therefore it will be T2G4 unevenly distributed. Jahn Teller distortion is expected. So in the second case, it is K4 again. So because of which here again there is a mistake. This should have been 4 minus. Since K4 is present here, it should be 4 minus. Please note this. This should have been 4 minus. And the corresponding oxidation state of Fe, it will be 2 plus, which is D6 system, and it will in the strong field it can be distributed as T2G6. Eg0, therefore even distribution. Jahn Teller distortion is not expected. So what I can say is, Jahn Teller distortion is expected here, whereas Jahn Teller distortion is not expected here. Similarly, if we continue with the next, quickly if we look at this, again this is a D6 system, and this one, if you look at it, is D5 system. So D5 here uneven distribution is possible. D6 uneven distribution is not there, even distribution, so no Jahn Teller distortion here. So what I can say is, in this case it is no Jahn Teller distortion. Jahn Teller distortion is expected here, so it's possible in A and D. Option A and D, the corresponding option is option C. So option C is the answer for this question. Hope this has helped you, and thank you for watching this video. Thank you again.